Okay, in this section I'm hoping to just introduce differentials as an idea. This is another form of linear approximation. What I'm going to do right now is just try to get some of the pieces put together before we start actually doing using differentials to find approximate values. So let's try that. Start with this, that the definition of differentials is let y equal f of x represent a function that is differentiable on an open interval containing x. The differential of x is denoted as dx. So this is really important that you keep this in mind, that this is dx right here, otherwise known as the change in x. So and it is any non-zero number. The differential of y, denoted as dy, is this: dy equals f prime at x times dx. This seems like kind of a big deal, but it's not. This is not a new concept, actually. If you look at it up here, we can see this, that I think that we can agree that dy dx is f prime at x. It's just stated in another way. And all I'm going to do here to try to create this piece at the bottom, to create this dy equals f prime at x dx, is I'm going to multiply both sides by dx. So dx in the numerator cancels out dx in the denominator. They go to 1. And then I multiply the other side by dx using the multiplicative rule of equality from algebra. So again, this should not be a big surprise. It looks kind of cool here, but it's not a big deal. It's just some simple algebra. Remembering here that this is a change in y over the change in x is equal to f prime at x. So this is just some notation for you to write down. I'm going to put this all together in the next video. But here, that we're going to say that the change in y, or delta y, is equal to the exact change in f of x. I promise it will make sense later. Where dy is the approximate change in f of x. And if that's true, then dy, this should be lowercase, but dy is approximately equal to the change in x. So what I did here is I'm asking you here to believe that dy is approximately the same as the change in y. And I'm telling you here that we prove this that dy is equal to this. So all I'm going to do here is I'm going to take this dy out here, and over here I'm going to put it in change of y. And I'm going to say change of y is approximately equal to f prime at x dx. Okay, that's a lot of stuff right now. Again, we're going to put it together in the next couple of videos. This should not be bad. Okay, let's just start by gathering our tools here and just start by finding some differentials. I'm not saying what it means. I'm just saying how would you find a differential. So you'd start with this function, and that's what we have here. We have the function y equals x squared. And we're looking for f prime at x, but for convenience sake, we're going to call it dy dx equals 2x. And that is true, that the first derivative of x squared is in fact equal to 2x. Well, if you want to find the differential, dy, then you would, just like we did at the top, we multiply both sides by dx. And dx will cancel out this dx at the bottom, and here's the other dx. So the differential, dy, is equal to 2x dx. Okay, going on to the second function, we have y equals 2 sine of x, and we have to remember our derivatives here. And the first derivative of sine is cosine, right? Is cosine. And this is going to drive me crazy. Is cosine. This is a constant multiplier here out in the front. So it's 2 times cosine of x, and that's what the first derivative is. dy dx is the first derivative. To find the differential, we're going to multiply both sides by dx, and we get that the differential is equal to 2 cosine x dx. So simple enough. Here we have a little bit more complicated function here. Just want you to keep in mind that the most difficult part here, in my opinion, is actually the differentiation. After that, it should be relatively simple. So we're looking at this. I put this multiplication sign in here to remind you that this is the product rule, right? So what I did on the side is I set up a table, and I found those values. I said that f of x is equal to x, f prime at x is equal to 1. This is me setting up my product rule. G of x equals cosine of x, and of course, g prime at x is the opposite of sine of x. And then I'm just putting this together. This is f of x times g prime at x plus g of x times f prime at x. And that's how we get our derivative here. Get our derivative here, and of course all we're going to do here is multiply both sides by dx, and we get the differential here is dy is equal to the opposite of x sine x plus cosine of x times dy. And lastly, so the last one I'm going to do here, before we move on to more complicated subject matter, is take this function y equals 1 over x. I'm going to change this bring this x up as a -1. Take the first derivative of this function here, which is 1 over x squared. So that's f prime at x, the derivative, dy dx. And then all I'm going to do is take the differential, find dy by multiplying both sides by dx. So all we've done so far is we've written down our definition. We've added a couple details here that we're going to use later. We've gone through some pretty simple steps for how do you find a differential. And we found out we take the function, we take its derivative, and then we solve for dy. And that's all there is. I hope this is helpful. I'm going to add the next video tomorrow, I promise.